To multiply rational expressions, like the ones given in this example, we could just directly multiply the numerators and multiply the denominators, but I think it makes more sense to first factor them and cancel any common factors. So let's start there. With the first fraction, let's see, we have x squared minus 2x minus 3. Can we break this up into a couple of pieces? And the same thing for the denominator. Can that be factored as well? Starting with the numerator, we have to have an x and an x. If we have a negative 3 and a positive 1, that would multiply to negative 3, yet add to 2, so that looks good. And for the denominator, we have, let's see, I want to multiply to 14 and add to negative 9, so that's going to be a negative 7 and a negative 2. And that's just the first fraction, and I see there's no common factors between the numerator and the denominator, so nothing cancels. But let's try the same thing for the second fraction. Okay, so I'm again hoping that this factors. Let's see, for x squared minus 6x minus 7, I have x and x. Okay, so it'll be a minus 7 and a positive 1. For the denominator, okay, an x and an x. That's going to be a negative 3 and a positive 2. Now that everything is factored in both of the fractions, I don't have to just stay within the first or the second fraction. I can look for common factors between any numerator and denominator. And I'm seeing that there's an x minus 3 here and there's an x minus 3 here. Why not cancel them first before multiplying everything together? So this and this cancel. Let's see what else we have. Okay, so there's an x minus 7 and an x minus 7. Those cancel. And there is nothing else that's left over. X plus 2 can't cancel into the x plus 1 on either fraction. And same thing goes with this x minus 2. It can't cancel into either of those. All that is left over is x plus 1 times x plus 1 divided by x minus 2 and x plus 2. I think it's completely acceptable to leave your answer like this. You could multiply them together. There would be nothing wrong with that. The answer would be x squared plus 2x plus 1 divided by x squared minus 4. But right here, that is a good answer where, okay, we've multiply the two fractions together, but we first canceled all common factors. Okay, so let's try this idea, but in a different example. So we have x cubed divided by x squared plus 3x plus 2. That's being multiplied to x squared plus 5x plus 4 divided by x squared plus 4. For the first fraction, there's nothing to factor. It's just x cubed. For the denominator, what do we have? We have an x and an x. Okay, it's got to be a plus 1 and a plus 2. Everything is positive there. For the second fraction, in the numerator, okay, let's see. If this breaks into two pieces, again, it looks like it's just an x and an x. This one will be a plus 1 and a plus 4. So, okay, those are all very straightforward. The denominator of the second fraction, there is a greatest common factor of x that can be removed from both terms, and I'm left with x plus 4. If I try to now cancel common factors, I have x plus 1 and x plus 1, x plus 4 and x plus 4. Now there's also this x to the first and this x cubed. That means this will drop down by 1 to 2. Left over we have x squared over x plus 2. And in the second fraction, the entire numerator is gone. It's just 1. And the same thing goes for the denominator. We canceled this x, so it's just a 1 as well. That second fraction is redundant. You can just put x squared over x plus 2, and you don't even need the parentheses around the x plus 2. You could just leave it like this. But there we go. We've completely multiplied these two expressions together by canceling common factors.